Just give me a minute. This was 10 more minutes is fine. I'm starting the key. I thought I would. Have any bus? That's the case.
So we are ready to get started.
Should we get started? So, there is some technical issue there. Whether I'm not able to use Can you also come this side? This is visibility. So for today we'll go with this. Maybe we'll have a question. Okay. Setting the solved problem. Right, solving problem. CPSC part is also good. Right. Any doubts you have? Any doubts? Have any doubts? So we'll do one thing. Shall we look at the same real numbers with a different perspective? Let's try to look at it in a slightly deeper perspective. Yeah. Now I have a question. Before you study it, whether it is math, science, whatever subject for that matter, right? What do you think is the most important part that you need to be good with? What is the most important part you need to be good with, or you need to concentrate on before you start doing something? You need to know the depth of something. Is what I think. Right? So generally, what happens when you look at problems, or let's say real numbers or polynomials or quadratic equations, for the matter, it is any chapter. It has a set of problems. The curriculum is designed in such a way that yes, these topics are there and you have these problems. But you know what is more important for me? I need to understand why we are studying in the first place. So generally what we do is, we study something for 10th standard. But is it only restricted for 10th standard? You studied something in 9th. Right? Is there any knowledge that you're able to see from your 9th standard is getting carried forward? In real numbers, where is it coming? Where are the basics from your 9th standard coming from? Number systems basically. So basically you talk about number system, that is where the concept of real numbers comes into picture. But do you think the concept of real numbers will stop with your 10th standard? 11th and 12th and throughout your life also here and there you'll be using real numbers. But only thing is, as an end user, for example, I'm using this phone, I'm an end user. I'm not concerned about how the phone is being designed or all this. So as an end user, we'll be looking only at the outer layer. But as science students, we need to have a better thought process, is what it is. Is it right? So you need to have a clarity of what kind of numbers you're dealing with, what kind of problems you're dealing with, why you're doing it in the first place. Is it just because we have it as syllabus? Or is it for the sake of understanding so that you can apply it in some other section? That is more important, right? So what generally happens is, you have to see math like a tool. How many of you read math like a formula research? Okay, this formula is there. I'm going to apply it here and got the answer. So be honest to do that, right? I know that now you're not alone. This happens with many people. But what I'm trying to say is, math also has a theory associated. If you understand the beauty of why you're studying things, right, then math becomes a piece of paper. It's not different. If you understand why this particular formula is there, you yourself can apply it. Okay. That is what we are going to work upon in the foundation course. At the same time, I'm not going to be like I'm going to take you too high also so that you're confused between what to do with boards and this thing. I'm going to be very careful with the fact that I'll let you with your boards. At the same time, make your foundation strong by ensuring that you understand the basics well and you ask the right questions. Okay, so what I want this class to be is interact more, ask as many questions as possible. There is nothing like silly questions. Whatever comes to your mind, ask. Because whatever doubt you get might be the doubt for others. It might be a doubt for me also, I'll be honest about it. Which I would have not thought of. It will be a learning for me also. That is what I say. Okay. So I'm open to questions and open to discussions. It is then we are going to have an interactive session, or is it going to be boring? Obviously, there is no point, right? You're spending so much of time here. So, when you study real numbers, right? For example, let me give you an example. Let me give you a perspective of why you are studying that with respect to your current syllabuses. Okay. So, first, if I put a question like this, how many of you know your math syllabus properly, whatever the chapter is? Without looking at the index, can you try telling me? I can try. I'll help you. First, you have what? Second, third, pair of linear equations and two variables. Fourth, quadratic. Arithmetic progression. Sixth, introduction to trigonometry. Seventh, in between you have triangles. Then you have introduction to trigonometry. Then you have the application of trigonometry. Then areas related to circles. First learn about circles, then you see how those areas are related. Then the construction that you have surface related surface area. After that, you have statistics also, followed by which you have probability. So if you are not known, you have these topics, right? So real numbers is completed, polynomials is completed, quadratic equations is completed. So pair of linear equations is completed. And at last you have probability that has been completed, right? Quadratic equation. So they are teaching, so you know something about it. Okay, I have an important. If you look at the first four chapters, right? What are they related to? What are you even trying to do? You're dealing with some equation. Real numbers generally don't have equation. You'll be playing with numbers. Right? Real numbers you have. Why are we studying real numbers? I can directly start with polynomials. Why do we have to? Because in your quadratic equation, for example, you have an equation ax squared plus bx plus c is equal to 0. Right? If I give you a 0 and I ask you to solve this, what is my expectation from you? What am I asking you? Why do you need to solve this? Simply sit. And find out that number and tell you. By doing that, what am I doing? Remove out of play. Okay. By solving that problem, what exactly are you finding? Ax squared plus bx plus c is equal to 0. What is it you are finding? You are finding the values of x. Correct? You take pair of linear equations. You have pair of linear equations. How many equations are the minimum number you need to solve to get the answer? If I give you one equation and here, one linear equation and two variables, I ask you to find out the value of x and y and tell me, will you be able to solve it? So I'll give you something like this. I'll give you 2x plus 3y is equal to 5. Tell me what is the exact value of x and y? Can you shift there? Or we'll try to move this. So 2x plus 3y is equal to 5 is there. Suppose I give you this equation and I'm expecting you to tell me what is the exact value of x and y. Will you be able to do that? There is nothing like exact value of x and y because you're free to substitute and do it. So how many variables do you have? You have two variables. So the number of variables you have is equal to the number of equations you need to solve. That is why when you take linear equation and two variables, you see every question you need to frame at least two equations to solve it. Minimum is 2. Maximum you can have any number. Then you will be able to solve it. Okay. Similarly, since you told quadratic equations has been started, ax squared plus bx plus c is equal to 0. Okay, this is the general form of a quadratic equation. If I write ax squared plus bx plus c alone, what is this called as? So I want you to learn the mathematical terms associated. This is a quadratic polynomial, whereas this is a quadratic equation. They both appear similar, but how am I able to classify them as polynomials and equations? Look at the expressions very carefully. What is missing in the first one? Equal to symbol is missing. So quadratic, what is the name of the chapter? Quadratic equation. Now what do you need to have? You need to have an equal to symbol. So if there is no equal to symbol, it becomes an expression. If there is an equal to symbol, it becomes an equation. So in your polynomial chapter, you can see that you would have not used the equal to symbol. Correct? Whereas in quadratic equations, everywhere you will use equal to 0, equal to 0. By doing this, you are finding out certain values of whom? Of x. For example, I have x squared plus 2x plus 1 is equal to 0. I am asking you what is the value of x. What will you do? I'll write this as x plus 1 the whole square is equal to 0. Then what is the value of x? Can I write it as plus or minus 1? Sorry, minus 1, minus 1. I'm sorry about it. I can write it as minus 1, comma, minus 1. So why did I write minus 1, comma, minus 1? Because quadratic equation, the degree is 2. So it tells me that I have 2 roots. I have 2 roots. And how are those 2 roots? Is what the question is. So minus 1 and minus 1. The same thing in your quadratic equation, how will you report the answer as? You will say this equation has 2 real roots of unique value. Have you heard this? Have you heard this at least? I'm not saying that you have solved. Real roots of unique value. Real and distinct roots. Have you heard such terms? Not yet? Okay. Not yet. Huh? Okay. Next time check your notes. If at all you are not heard, next time you'll be hearing this. So maybe I'm telling you for the first time. So what you will tell about this is you say this quadratic equation has real and equal roots. Okay. If suppose I have an equation x square plus 5x plus 6 is equal to 0. Then I'll have x plus 3 into x plus 2 is equal to 0. So x will be equal to how much? Minus 2 comma minus 3. You know how to factorize, huh? Factorization you have learned, no? So using that only I solved. So minus 2 and minus 3 for this quadratic equation, you will report the answer saying they have real and distinct roots. So if you observe, what is the word I am using again and again? Real. So basically, for you to solve a quadratic equation, you need to know when will you get a real number and when will you get the opposite of real number. Any idea about what is the opposite of real number? It's called imaginary number. Okay, you need to know about them. Are you able to understand, guys? But the basics for all these things comes from the concept of number systems. Why is number systems important for us? That's what we'll first see. Okay. So I'm just going to touch upon certain basics from your 9th standard, then I'll connect it to your 10th. Okay. It will take only 15 minutes max. I want you all to speak out. 1 minute. So if I put a question like this, why number systems? Why do we need numbers in the first place? Whether it is real number or imaginary number, why do we need it in the first place? Can you guess? Basically, what we do is counting. So to count something or to measure something, you need to deal with numbers. Okay, that is on a real-time basis. For example, you have number of books, number of pens, number of pencils, all these things you need to count. Suppose, let's say you have a medical inspection happening. They want to check your height and weight. What do? They check your height and weight and they write it in terms of number followed by a unit. So those numbers are called as physical quantities because they are measuring your height, weight, all these are physical quantities. Okay. So for that you need numbers. So numbers comes from mathematics. It is applicable in science also because 161, does it make sense? Your height is 161 if I tell you something like that. Does it make sense? Because what will you ask this? What is that 161? Is it millimeter you're trying to talk about? Centimeter, meter, what are you trying to talk about? So you need a unit term. So you talk about centimeter. Right? So the number is a unit. So this is actually physics. That is why we call it as physical quantity. So to take the help in science also, you need numbers. And most importantly, every calculation we do in our day-to-day life. See, for example, the marks you get, the marks for which the question paper is being set, everything has a number associated. Right? So that is a simple thing. But I want to take it slightly to the next, that everybody knows. Now let's think of how is this applicable in computers. Coding. Can I take this call? Yes, sir. Yes. Where is it applicable? You told the word coding, right? So generally when you write this coding, right, what language do you use? Basically, Python or Java, whatever you are going to type in English. But will computers understand English? What will they understand? They understand numbers. So when you type something, when you compile it, right, when you run that program, you have done it, right, obviously. When you run that program, you will be able to see an output, right? So what is the language in which it gets converted to computer for it to understand what code you have written? It gets converted to zeros and ones. So that is also a number system. So what is that number system called as? Zeros and ones, two numbers. So it will be a combination of only zeros and ones, 0, 1, 1, 1, 1, 0, something like that. But whole mathematical expression, if you take, you will only find two numbers in it. What are they? Zeros and ones. So what kind of a number system is that called as? Any idea? Call it as binary number system. Similarly, I have something called as a decimal number system. So that's what we are using, right? So for decimal number system, what are the numbers that we use? If you want to represent 100, what will you use? You use 100. Okay, if you want to represent 125, you use 125. 129, 129. So you, for all the digits that are present in that particular number, we take the help of numbers from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So how many numbers are we taking into consideration? Not 9. 9 plus that 0 is there. No? So you take 10 numbers. So decimal is derived from deca. Deca means 10. Deca is 10. Okay. Binary means by is 2. That is why you call it as binary. Similarly, you have different kinds of systems in that. So just like give you an introduction to what are the number systems that are present. One you have decimal, one you have hexadecimal. Have you heard of this? See, for example, you have your computer, you have motherboard. In that motherboard, you have heard of this processors. They say this i5 processor, i7 processor. Those are all hardwares. So those processors will not be able to understand binary language. They will be able to understand a language called as hexadecimal. Hexadecimal is 16 digits. But we don't take 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You don't take 10, 11, 12, 13, 14, 15. So you take 0, 1, 2, we're able to see it here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And the remaining are the first 6 letters from your English. A, B, C, D, E, F. So it will be a combination of those terms. That is the language which machines can understand. That's called machine level language. You're able to understand this? Similarly, you have another system called as octal system. Octa means 8. So every system starts with a 0. So octal system goes from 0 to 7. So if you observe the important context here, why I wanted to tell you this, you're able to understand the importance of number system. You're not learning it only for the sake of your textbook or math. So it is applicable mostly in your computers. Mostly, I'm not sure mostly, it is applicable. One of the applications is computers. One of the applications is in medical, including your roll number, right? If the school has to maintain, there are 2,500 students studying here. So if they need to have your roll number, your section, everything should be organized. For that, we need to take the help of numbers. So why do we call it as number systems? There is a system. There is a proper systematic way of placing these numbers. That's why we call it as number system. In that number system, one of the byproducts is what is your real number system. Okay. Okay. So you know what is the system? It's a number line. So a number line, what do you represent on a number line? What numbers? You have different kinds of numbers. Will you represent natural numbers alone? Will you represent whole numbers alone? Will you represent only rational numbers? You can represent real numbers. So that is where the question comes of what does real numbers comprise of? Real numbers comprise of natural numbers, whole numbers, integers, rational, and irrational. So if I have to give you a circle, it looks something like this. Real numbers basically consist of, so I'll zoom and show you. It consists of rational numbers, integers, whole numbers, natural numbers. Okay. And the next part of the counterpart of rational number is what is irrational. Okay. Have you ever, so in this year you have something like this. Last year you would have had a concept like plot this irrational number on a number line system. You will take that compass and cut an arc and you plot it on the number line. I hope you would have done that. But this year they would have asked you to prove that given you that the number is irrational. So you have that we follow. But before we follow that, we need to have an understanding of why we are doing it in the first place. But how many of you have clarity of why you're doing it? You would say, I'll ask you to do the root 2 is a prime number. What will you write? Let's say, sorry, root 2 is an irrational number. What will you do? You'll write, let's say it is a rational number. So when it is a rational number, it can be represented in the form p by q. Then you will write root 2 is equal to p by q. P is equal to root 2 q. You do all these things. You square on both the sides and then again follow, right? So why are you doing it? Can someone give me an explanation? Why are you doing it? Just because the procedure is like that? Irrational number. But irrational numbers are what? So if I ask you a question, a direct question stating that you exactly tell me what are irrational numbers and how do they look like? If I give you a number, looking at that number, how do you say it is an irrational number? It's continuously. So I'm happy that you came at least to that point. Non-terminating, non-recurring, something you're trying to answer, right? This is where the difference starts. Okay. So this is what I wanted to explain. Okay. So I'll just go through these slides a little fast. Okay, because these are all the things that you know already. What are natural numbers? 1, 2, 3, 4 till infinity. Okay, what are whole numbers? 0. So the natural numbers, if you add a 0, you call it as a whole number. So if you look at the right. Here they have not given it. So I'll just give you. See, if you look at natural numbers, right? So you know what is a set? You have heard of this word set. So basically, what is set? Set is a collection of similar items, which you will be learning in depth in your 11th grade. It's not a big thing that you need to wait till your 11th standard. Okay. See, for example, 4 of you have a book. So if you look at this book, every book is having the same color, right? Same data written on top of it. So if I collect all your books and stack them up, I keep it there. I can call it as set of MTG, Foundation Course Mathematics Class 3. Because it falls under this category. What set does that stack belong to? Similarly, I take all your class notes, I stack them up. What do I say? It is a set of all classwork notes of student from this class or this section. So set means basically collection of similar items. So if you collect those numbers starting with 1 till infinity, you call them as natural numbers. So generally a set is written within this kind of braces, flower brackets. Okay. If you write something like this 1, 2, 3, so on till infinity, means you're telling the person who's reading your paper that you're talking about natural numbers from 1 to infinity, and natural number set is represented by the symbol capital N. Okay. Capital N is natural number set. Okay. Similarly, if you open a flower bracket and you start writing from 0, 1, okay, if you open a flower bracket 0, 1, 2, 3, so on till infinity, somebody who's reading your paper, what are you trying to tell them? You're talking about whole numbers. So this is a set. So this is the name of the set. So the set whole numbers is represented with the symbol capital W. Capital W. Okay. Set name is always positive. Suppose I take the set of negative natural numbers and whole numbers. What can I call that set as? I can call that as integers. So how you represent them? You start something like this. So dot 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 minus 4, minus 3, minus 2, so on till 0, 1, 2, 3, so on till infinity. So you call this kind of a set as an integer set. How is integer set represented? It is represented with the symbol Z. Are you able to understand? Yes. So if somebody tells you Z, that's it. What will you tell them? Because they're trying to talk about integers. So integers should run in your mind. Okay. Now comes an important question. What is a rational number? This is the answer I get commonly. P by Q where Q is not equal to 0. But I want more clarity. When I say P and Q, those are numbers, okay. But what kind of numbers are they? Are they natural numbers? Are they whole numbers? Or are they integers? next time when you say, right, if you write any number in the form P by Q, in the form of a fraction P by Q, where Q is not equal to 0, and P and Q are what? Integers. Then that kind of a number is what is called as a rational number. Rational number is a real number. So real number is the biggest set. Under that you have rational. Under that you have integers. Under that you have whole. Under that you have natural. So the other category is irrational. Correct? Huh? Okay. So rational number means, please write it down. I want you to write. You have a separate notes? Please use them. A number which can be put in the form P by Q. Number which can be put in the form P by Q, where Q is what? The Q is not equal to 0, and P comma 0 represent what? P comma Q represent integers. Okay, so when you're writing P and Q, right, write them in the lower case, don't write them in upper case. I'll tell you the reason why. So, however it is given here, see. You're not able to see it. Why? Because small p and small q are coming from the set. So those numbers are there, right, in the set. They should always be, so instead of numbers, if you're using variables, those are called as elements. So this -4, -3, -2, all are called as elements of the set integers. Are you able to understand? So set name should be in capital. The elements of the set should be in lowercase. So when you're writing P by Q, right, you should not write capital P by capital Q, because if you write capital P, you're representing set of irrational numbers. If you're writing capital Q, you're representing set of rational numbers. So if you write capital Q, by default, people will think that you're trying to talk about set. No, you're talking about the element of this. Am I clear on this? No confusion, right? Okay. So that is one way of defining it. This is simple. Okay, now I have a question. If I take two numbers, 1 by 2 and 1 by 3, okay, can I call these two numbers as rational numbers? According to the definition that you wrote, can I call them as rational numbers? Yes, I can call them. So when I write the same rational number, is it always necessary that a rational number should always be written in fraction? There will be some people in this world who are not comfortable with fractions. They want to write it in decimal form. What about them? So if they want to write it in decimal form, somebody will report the answer. See, for example, when you use this 1 by 2 and 1 by 3 probability, right? You can say 1 by 2 or 1 by 3 in fractional form, or you can say 0.5 or 0.3 with a bar on top of it, correct? So when you say 1 by 2 and 1 by 3 are rational numbers, what helped you to decide and conclude that they are rational numbers? What ran in your mind to conclude that they are rational numbers? That is the second thing. But how did the fraction help you? Look at the definition clearly. P is a integer. 1 is an integer, 2 is also an integer, right? And the denominator is not equal to 0. That is there. But when you solve them and write it, you get 0.5 and 0.3 bar, right? So one important point with respect to a rational number is they will be either terminating or non-terminating, like 0.3 bar. But most importantly, what will they be? When they are non-terminating, they are repeating itself. They will repeat itself. So repeat is basic English. Technical English is, the mathematical English is recurring. Okay. So able to understand, this is the most important point you need to have in mind. So when they give you a fractional value, if you divide that fractional value and the fractional value is able to generate a terminating or a non-terminating and repeating value, then you can call that number as a rational number. Okay, please write down this point. So rational number is either a terminating or non-terminating, but a repeating decimal. I've underlined this. Rational number is either a terminating or non-terminating, but recurring. The bracket you can write it down as I hope I'm not fast. Now, when you talk about the sign of it, so how can a rational number? Is it always positive, always negative, or how is it so? It can be positive or negative or zero as well. Right. So, having said this, we can now discuss about the other two, which are called as factors and multiples. Complex numbers, as of now, don't worry. It's a part of the notes. Complex numbers, I'll explain you slightly in a later point. So now I need to concentrate more on factors and multiples. Can you tell me why? Are you dealing with factors and multiples this year? Time factorization is there. Okay. But most importantly, what do you have? You have something called a Euclid's division lemma, right? Why do you even use it? Finding HCF. So what is HCF, the full form? Highest common. The third word is more important for highest common factor. What is the other name for HCF? It starts with G. GCD. It's called greatest common divisor. So HCF or GCD. What is the counterpart of it? Least common multiple. So third word is multiple. So what does it mean to have grip over? Multiples and factors. Because in polynomials, have you ever seen they would say x plus 3 is a factor of this polynomial? Have you ever thought what they're trying to say? Means that polynomial can be divided into smaller cases, where those smaller cases are what are called as factors. So let's try to understand with a simple example. Okay. Now I have, let's say, 24. I took some random number. If I ask you what are all the factors of it, what will you say? Factors in the sense 24 can be written as the multiples of which numbers? I can start with 1. So 8, 12, 24. An easier way to do this is 24. This is what you do in quadratic equation. You start with 1, you write 24 here. You start with 2, you write 12 here. Means this side you will be doubling and this side you will be making it half. Correct? So this, if it becomes 3, what will you? 8. So I'm not doubling it, so I have to take the number. So 4, if I take it, 2 is double to 4, 12 will be half to 6. Does it make sense? So 6 is there, 4 will come again. 12 is there, 2 will come again. It's a repeated thing. And lastly, 24 is going to be there. It is going to be 1. So what are the factors of 24? 1, 2, 3, 4, 6, 8, 12, 24. So factors are basically the building blocks of a multiple. Can I say something like this? So that is when you will understand when to find HCF, highest common factor. So among 24, I write something like this. Okay. For 12, if I put a question like this, for 12, tell me the factors. 1, 12, 2, 6, 3, 4. That's it. No, 4, 3, I will not write it because it's the same thing again. 3 into 4 is the same as 4 into 3. 6 into 2 is the same. So these are all the factors, right? So if I write the factor set for 24, what is the factor set? 1, 2, 3, 4, 6, 8, 12, 24. Here, what is the factor set? 1, 2, 3, 4, 6, 12. Now, recollect what is HCF? Highest common factor. So it has 1, 2, 3, 4, 5, 6, 7, 8. And this one has 1, 2, 3, 4, 6, 12. So 6 factors. Here it has 8 factors. But what is the number which is highest in both and common in both? So that is why you say HCF of 24 and 12 is 12. So if you look at it, is it not confusing us? You're using the word highest. Between 24 and 12, highest is the word you're using, but you're taking a lesser number. Did you ever think of this? But when you do LCM, what we have? LCM of 24 and 12 is 24. You use the word least, but you take a bigger number. That's how math works, right? Because we need to be very careful. Then I've seen people getting confused. So what is the context behind it? Between these two sets, what is the highest common factor? That is what you're taking. That is why you're using Euclid's division lemma, because here it was simple for me, 24 and 12. If I give you a big number, 102456 and 758, and if I leave you, You have to sit and write factors this side, you have to sit and write factors this side. Manually, you have to check which is the highest common factor. It take ages. So that is why they came out with the algorithm. Okay. So now you are getting a grip of it. Right? So least multiples, where do you use it? You use it in the case of least common multiple. So least common multiple means what? So why do you call them as least common multiple is, if I take 24 and 12, what is the common multiple of both? Means which number is divisible by both so that it does not give us a fractional value. It is obviously 24. What else is the other number possible? It keeps on going, right? So I can write it like this. I can write 72. So these are all the common multiples. Understand? These are all the common multiples of both 24 and 12. Means they exactly get divided by 24 also. They exactly get divided by 12 also. But what is the least value among them? That is why you take that. That is the reason why you take that. That's why we call it as LCM. Are you able to understand this? Now, having said this, if I have to give you a simple diagram of how factors and multiples are related, when factors are multiplied, what you get? You get a multiple of those factors. But if a multiple is broken into smaller parts, you get the factors. So this is how they both are related. You can draw this diagram. So basically, factors are smaller numbers, multiples are bigger numbers. So they can be multiple, they can be numbers or they can be expressions also. For example, x plus 3 is a factor. Okay. In quadratic equation, you will learn x is equal to minus 3. So that minus 3 is a root. So look at the mathematical language. X plus 3 written as an expression is a factor. But x plus 3 is equal to 0 means what is the value of x? Minus 3. That minus 3 is called as root. This is how it's called. Okay. So next time when you're studying, right, you need to ask this question. Like what exactly we are trying to talk about. Okay. Then you have even numbers, odd numbers, and all those things which you already know. What are even numbers? Numbers which are every integer which is a multiple of 2 is what we call it as even number. So how do you generally represent even number as 2 multiplied with a number n, where n belongs to which set? N belongs to integer set. So you can take any integer and substitute it there. For example, 2 into 1, 2, 2 into 2, 4. So all these numbers are even numbers. Now, if I have even number, how do I write an odd number? See, for example, I take a number line. I have 6. 6 is an even number. So what are the odd numbers associated with 6? So 5 and 7. Right? So what is the general way of writing this? To an even number, if you add 1 or subtract 1, you will get an odd number. So even number, if you add a 1, you will get an odd number. Or so to the same even number 2n, if you subtract a 1, you will get an odd number. Is it always necessary that you need to subtract only 1? Subtract. Is it necessary that you need to subtract or add only plus 1? Only 1? You can add 3, you can add 5. So you can add any of the odd numbers, but the least value that you can add to get an odd number from an even number is 1. That is why I wrote it as 2n plus 1 or 2n minus 1. Okay. This point, please make a note of it. This will help you for your Olympiads. Any doubt? Clear? Right. So this is the words prime and composite number. What are prime numbers? Numbers which have factors as 1 and itself. Right. So if that is the context, can I call 1 as a prime number? So by convention, 1 is not a prime number at all. Then what you will say? Prime numbers start with 2, 3, 5, 7, 13, 17, 19. It keeps on going. So except 2, mostly you have all the prime numbers as odd numbers. You understand? So any number which is not a prime number is what is called as a composite number. Why this prime is important is because you have something called as fundamental theorem of arithmetic. In fundamental theorem of arithmetic, what you actually do to a given number, you do prime factorization. Prime factorization is what you do. Right? So at that point, you need to know what is the prime and the composite number, because they would have asked the question also like this. Write a composite number in terms of prime numbers. Have you seen the questions there? Right? So next time, concentrate on that. And one more point I want to add here is something called as co-primes. Have you heard of this word? What are co-primes? Yes. So co-primes are, you have not heard of it, huh? Okay. So where do you use a co-prime? You use it in one of the algorithms. When they ask you to prove the given numbers as irrational, what you do is you do it using quadratic method. You will say that these two numbers are not co-primes. That is why they cannot be rational. They are irrational. That's the place where you use. So co-primes, write it down. Two numbers have the highest common factor as 1. Two numbers have the highest common factor as 1. Highest common factor as 1. So this is one way of defining. What is the alternate way? Or the numbers which do not have any common factor, or the numbers which do not have any common factor other than 1. Or the numbers which do not have any common factor other than 1 are called as co-primes. Thank you. Yeah. So if that is the case, I just want to conclude by saying that this is how I think I've already shown this, right? So this is how real numbers are classified: rational, integers, whole numbers, natural numbers, and irrational numbers. Now one point we need to see: what are irrational numbers? What are irrational numbers? Can you come again? So basically, they are non-repeating and non-recurring. Okay, so write it down, because you would have thought that irrational numbers are those numbers which cannot be represented in the form e by u. That is accepted. You cannot represent it. But at the same time, the most important definition that you need to take into consideration is any real number can be called as an irrational number if and only if their decimal representation. So, for example, root 2 is there, right? Root 2 you can write in the form of decimal. If their decimal representation does not terminate or does not repeat itself, we call it as an irrational number. Please write down this definition. Write down the first definition. All real numbers are irrational if and only if all irrational numbers are all real numbers are irrational if and only if their decimal representation is what? Is non-terminating and non-repeating. The decimal representation is non-terminating and non-repeating. We call them as irrational numbers. Examples: root 2, root 3, root 5, pi. All these are irrational numbers. Right? Right? So now we are almost ready to start solving the problems from center. Before that, we discussed about rational numbers and we discussed about irrational numbers. Now what we have is to take combination. Okay. So the first thing is collection of rational numbers and irrational numbers put together is called as real numbers. So that is known to us. Secondly, if you have A and B as two real numbers. So when I say real numbers, they can be rational or irrational. Then what are the kinds of relations you can form between them? One real number can be greater than another real number. That is, A can be greater than B, or one real number can be equal to another real number, or one real number can be less than another real number. So A can be greater than B, or A is equal to B, or A less than B is one of the relations you can form. Similarly, if I have an irrational number and if I take the negative of that irrational number, what will it be? Still an irrational number. I have a question. If I take a rational number and add it or subtract it from an irrational number, what will you get? Can you give me an example? So you're able to understand? So you take a rational number 2 and you take an irrational number root 2, you add it to it or you subtract it from it, the output is still going to be is always an irrational number. Correct? Is it right? Next is the product of non-zero rational number. If I take a rational number and multiply it with an irrational number, what will I get? I'll still get an irrational number. For example, 2 into root 2. 2 root 2 is still an irrational number. Okay. The sum of two irrational number, this is very, very, very important, is not always an irrational number. Does that make sense? Root 2 minus root 2 is 0. But here they told sum. What you told is right only. That is also difference only. Okay, minus correct only, but yeah, sorry. Root 2 plus root 2 is 2 root 2. 2 root 2 is still irrational. What you told is right. So what she told is, she told 2 minus root 2 minus root 2. Okay. Can I write this as root 2 plus root of minus of root 2? What did I tell you in one of the points? Negative of an irrational number is also an irrational number. This is one irrational number. This is another irrational number. Right? So sum of this is going to be 0, which is not an irrational number. Or the other way of looking at it is, I have 2 plus root 3, which is irrational, plus 2 minus root 3, which is an irrational. If I add them, I'll get 4, which is a rational number. So 2 plus root 3 and 2 minus root 3, what are they called with respect to each other? You know this word already. It starts with C. Sorry, can you come again? Constant. 2 plus root 3 and 2 minus root 3. There is a sign difference. C-O-N J. Conjugate. So they are conjugates of each other. You know, I have heard this word, right, in your 9th standard. When you need to rationalize the functions, you multiply and divide it with the conjugates of that. Right? Absolute is different. Absolute is modulus. Absolute of that number is modulus. We'll discuss about it later. Okay. Similarly, see these things will help you this year because they would have asked you certain problems. Like prove that 2 plus root 3 is an irrational number. You can say 2 is a rational number, root 3 prove it as an irrational number, and you will say that sum of rational plus irrational is always irrational. Are you able to understand? So similarly, if you take the product of an irrational and rational, product of two irrational numbers, they need not be always irrational. For example, if I take root 2 into root 3, what will I get? I'll get root 6, which is also irrational. But if I take root 2 into root 2, what will I get? 2. Root 2 into root 2 is 2, which is rational. So they need not be always irrational. Is that clear? So this is all about the basics of your number systems. So with this knowledge, we are ready to solve the problems and we can go faster because you know the basics better now. So shall we get started? So the first thing that we need to understand is the Euclid's division lemma. 1 minute. Okay. First, we'll go with Euclid's division lemma. So what does it say? State. We'll go from your textbook. You can have it open. So Euclid's division lemma. Can you go to the 6th line and read? What is the page number? In page number 1, go to the 6th line, page number 1. Go to the 6th line and read. If you have two integers, right? If you have two integers where you have an integer a and b, and you're dividing a with b, then how can you write the integer a in terms of b? So a is equal to bq plus r. So let's take an example. For example, I have 7. I'm dividing it with 3. So how do I write it? 2 times 6 and 1. I didn't get the remainder as 0. So how can I write this? 7 is equal to 3 into 2 plus 1. So 7 is a is equal to b into, what do I call this 2 as? Quotient plus the remainder. Now the question is, what is the maximum value the remainder can take? So remainder, the maximum value, it should always be less than, it cannot be less than or equal to, it will always be less than one number less than the number which you are dividing, less than b. So r should be less than 2, but it can be greater than or at the max equal to 0 also. If the remainder comes as 3, for example, okay, if the remainder comes as 3, then what you can do is you will put 1 here and you can put 3 here and you will get 0. So the remainder can't be 3. Now b is, so you're asking that, I thought you're asking about remainder. So this thing is clear, right? Oh, so you're saying, sorry. You're right. That's my mistake. Correct. So there's a, so r should be greater than or equal to 0, but strictly less than. What do I mean by strictly less than? It cannot be equal to 0. So there's a meaning. So r is greater than or equal to 0, less than. Okay. Now the question is, where do I use this algorithm? What am I going to do with it? To find the highest common factor. So if I need to find the highest common factor for two given numbers, what will I start doing? So dividing. Can we take an example and start solving it? There is a question at the back of the book. So tell me. Okay. See, we discussed about this thing, no, 12 and 24. Shall we start with this? So 12 and 24, what is the highest common factor? 12. So how do you get that? Take the bigger number, put it on the left hand side, is equal to 12 into 2 plus how much are you going to get? 0. So you should stop exactly till you get the remainder as 0. When you get that 0, the value which is present here will become the highest common factor because you're breaking them into chunks. Okay. So having the same knowledge, shall we start? Give me another problem. 595 and 721. So take the bigger number, write it in terms of 595. Okay, write it in terms of smaller number into. Can I write it as 1 plus what is going to be the remainder? 721 minus 595. So I'm able to see a 6. 11 minus 9, 2. I'm able to see a 126. Okay, this is going to be the remainder. Now what I can do, I will divide this 595 with the remainder that I'm getting. So 595 is equal to 126 into, what will I write? 126 into, so 126 2s is 252. So 252 into, okay, 126 into 3 is how much? 378. 378. So 378 also. So 126 into 4 is how much? 24, 2, 6, 8, 5, 504. So I can take it as into 4 plus what are you going to get the remainder as? So this 126 again I will write it in terms of 91. 91 into 1 plus what is going to be the remainder? 35. So 91 again I write it in terms of 35. 35 into 2 plus 21. So 35 I'll write it as 21 into 1 plus 14. 14 I will write it as, sorry, 21 I will write it as 14 into 1 plus 7. So 14 I will write it as 7 into 2 plus 0. So I'm getting remainder in this step. So in this step, whatever is B is going to be the highest common factor. But is there a way we can directly find it? Yes, provided you sit and write the factors for 595. You write down all the factors for 721. See which is the highest common. Instead of that, we have something called as Euclid's division. Okay. So this is one of the steps. Next is you have something called as fundamental theorem of arithmetic. What does that say? So you know what is a composite number? What is it? Numbers other than prime numbers. So every composite number can be written as. So product of primes. Bracket you have given something called as factorization. Right? What is the meaning of it? It means you break them into factors. Now read the statement again. I want you to understand. So every composite number can be written as a product of primes irrespective of the order of the prime in which you are going to get the values. So what is the meaning of that? Irrespective of order of the primes. So doesn't matter which prime number you are writing first. So 2 into 3, like how we told, 2 into 3 can be written as 3 into 2 also. But still, it is going to give you the composite number 6. Okay. So how do you solve them? So how do you solve? Like how do you find? You see prime factorization method, right? So shall we do a problem based on it? So HCF and LCM using prime factorization method. So how to find that? Okay, let us go to page number 3. Look at example number 4. Okay, let us look at example number 4 first. Write the prime factorization of the number 27300. In this factorization method, find the total number of primes and number of distinct solutions. So you know what factorization, right? So what is the number? Write down the number alone. 27300. Write it as prime factorization. With what will you start? Let's start with 2. Keep doing it. Or the answer? For the answer. So the total number of primes that you have. 2 power how much? 2 power 2 into 5 power 2 into into 13. No? 7 is there, no? Okay, 3 into 7 into 13. So if you add all the powers, 2 plus 2, 4, 5, 6, 7. So totally how many primes are there? Yeah, 7. But what is the next part of the question? What do you mean by distinct? You cannot count it if it is getting repeated. So what are the distinct primes you have? 2, 3, 5, 7 and 13. Okay. So this is going to be the answer. So you have totally 5 primes. Now the next question is, how is this prime factorization method of writing a composite number in terms of its primes going to help us to find the HCF and LCM? So how is it going to help us? How does the fundamental theorem of arithmetic help us? You have solved our problems already. So if suppose I have 3 numbers in my hand, okay, and I want to find the highest common factor among both. So how you? For example, let's take the 2 numbers itself. You have 12 and 24. Let's go back to the same example. So for 12, write down all the prime factor. Write down in the form of prime numbers. Break 12 into the form of prime numbers. 12 is equal to 2 power 2 power. Okay, what about 24? 2 square into 3. Okay, now what does HCF tell you? How do you find HCF from this kind of a combination, from the fundamental theorem of arithmetic? If you write a composite number in terms of its prime numbers, how do you find the HCF from this 2 data? So read the statement below fundamental theorem of arithmetic statement, right? There is some important point given with respect to HCF and LCM using prime factorization. Read it slowly so that you are able to understand the product of okay. So what is it you told? 12 is equal to 2. 24 is equal to 2 cube into 3. So among these two, what is the smallest power that 2 has? So 2 square into what is the smallest power that 3 has? So 3 power 1. So 2 square is 4. 4 into 3, that is 12. So this is what you got by using normal method, by using Euclid's division algorithm, and by using prime factorization. So these are all different ways of finding the answers. Now the question is, we have 3 values given. Okay, 3 composite numbers given. How do you find the HCF? So shall we try that? Look at illustration number 5. Find the LCM and HCF of 9, 117 and 729 by using the prime factorization method. Can we do it fast? Good. So 9, how will you write it? Directly you can tell me. 3 square. So 9 is equal to 3 square. Hmm. 117 is 3 square into 13. 729 is look at the solution. 729, try to do it on your own. 3 power 6. So 3 power 4 is 81. 3 power 5 is 243. 3 power 6 is 729. Okay. So it is 3 power 6. So what are the numbers that you have got? 9 is 3 square. 117 is 3 square into 13. And 729 is 3 power 6. So among all these things, what are the numbers that is common? 3. So you take 3 to the power of least value. So which is the least value among all the 3? 3 square. So what will be the answer? 9 is the highest common factor for all these 3 numbers. Okay. Next is, how will you find LCM? How will you find LCM using prime factorization? What did they say? The last step. Product of the greatest power of each prime factor involved in the factorization of number. So what is the answer? Product of, read the statement again. Product of the greatest power of, so HCF, what is there? Read the statement carefully. I'm just trying. Why I'm saying this? Now read the statement between HCF and LCM. In HCF, what is the important word you are able to see which is missing in LCM? Right. So HCF, if you read it again, HCF and LCM both are product. So for HCF, I'm reading product of smallest power of what? Of each common prime factor. So in the previous problem, if you see, we didn't consider 13. Why? Because 13 is not common to all, but 3 is common to all. So I'll take all the common terms, and for those common terms, I will choose the least powers and multiply them. That will give me HCF. Whereas for LCM, what does it say? Products of greatest power of each prime. Please underline that word, each prime. Each prime factor involved in the factorization. Underline it. Okay. So what is that? You see 3 square into 13, 3 power 6. So product of the greatest power among all the 3, what is the greatest power of 3? For LCM, it is 3 power 6 into what is, so 13. 13 highest power is 1. So 3 power 6 into 13, it is going to be 729 into 13. Whatever is answer, that is going to be 9477, which is the least common multiple for all these 3 numbers. Are you able to visualize it? Now, one thing is, I want you to multiply 9477 and 9 and tell me what are you going to do. 9477 and 9 multiply. 9477 into 9. Sorry? 85213, 293. So 85293. Now, I know it is a little tedious, but can you multiply once? Okay, I'll do it as in the calculator. Tell me the 3 numbers that are given there. 2 into, not 2, sorry, 9 into. 9 into 117 into 729. Okay, this is what you are getting. This, did you get that 84 something you told? Okay. So can you tell me again? 9477 into 9. So it doesn't work. Okay. So if you have only 2 positive integers, okay, for example, 12 and 24 is there, right? What is the highest common factor for 12 and 24? 12. Okay, into what was the LCM for 12 and 24? It is 24. So it is 288, correct? So generally, when you have 2 positive integers, okay, when you have 2 positive integers A and B, if you know the HCF and LCM of those 2 numbers, then HCF of A comma B and LCM of A comma B should give you A into B. You know this fact, right? So sometimes what they do is they give you the number, they give you the LCM. Then they ask you to find the HCF, how will you use it? You have to use HCF into LCM is equal to A into B, but this is applicable only for 2 numbers because here it didn't work with LC. For 3 numbers, it will not work. So it is going to be only for 2 numbers. Are you able to understand? So here it is given, see the competition window, last point for the day. For 3 positive integers A, comma B and C, HCF of ABC and LCM of ABC is not equal to A into B into C. We checked it and we failed also. Similarly, LCM of ABC will be equal to A into B into C into HCF of ABC by find the separate HCF of AB, HCF of BC, and HCF of C. Okay, that is the thing. If you rearrange it, if you take HCF of ABC, then what will it be? It will be A into B into C into LCM of ABC divided by LCM of AB, LCM of BC, and LCM of AC. This is a slightly higher order thing, which is not a part of your NCM. You mark it as important. Okay. So mark it as important. And the same problem that we did know, example number 5. Okay, you can try for that and see. You can try for that and see as a part of homework. So next class, mostly I'll be completing this one. So we'll complete and we'll go to the problems. Do you have any doubts from the problems? No doubts, easy. Huh? Or you didn't try properly? Sure, you don't have any doubts? Okay. Let me check your notes. I told you about the notes, right? So please scan it and upload it as PDF. Okay. Sorry?